When we think of historical titans of science, we usually picture these austere, highly serious figures in tweed jackets locked away in ivory towers. But in today's explainer, we're looking at a man who shattered that mold entirely. We're talking about the life and mind of Richard Feynman. Yes, he was a Nobel laureate. Yes, he was a monumental intellectual figure of the 20th century. But he was so much more than that. He was the ultimate demystifier of the subatomic universe. He was a guy who helped calculate the explosive yield of the very first atomic bomb, and a true visionary who predicted quantum computing decades before the hardware to build one even existed. Okay, let's dive into this with a brilliantly insightful quote. The Polish-American mathematician Mark Koch categorized scientific minds into two distinct buckets. The first is what he called the ordinary genius. That's someone whose brain works exactly like yours or mine, just vastly faster. But the second archetype? That is the magician. A magician's intellectual leaps exist in a completely different dimension, making their methods almost incomprehensible to their peers. And Mark Koch unequivocally declared Feynman to be a magician of the highest caliber. That idea of the magician is really the thematic arc of our entire journey today. So here is our roadmap. We'll be exploring 6 key chapters today: the magician of physics, the making of a genius, rewriting the laws of physics, the bohemian scientist, the Feynman philosophy, and finally, the final act. We'll be covering dense quantum physics, for sure, but also safecracking, bongo playing, and a truly powerful cognitive defense mechanism. Chapter 1. The Magician of Physics, Demystifying the Rate Explainer. Feynman took the world stage by breaking down those rigid, aristocratic academic barriers of the mid-century. Let's move to and see how this builds in Chapter 2. The Making of a Genius, From Queens to Quantum. Growing up in Far Rockaway, Queens, young Richard was a notoriously restless tinkerer. He literally turned his childhood bedroom into a makeshift electronics lab. He used to fix his neighbors' radios simply by thinking through the circuitry in his head. But the absolutely crucial point here is how he was taught to think. And this brilliant distinction comes directly from his father, Melville, who was a uniform salesman with this huge, unfulfilled passion for science. Long before young Richard could even read, Melville would sit him on his lap with the Encyclopedia Britannica. But he didn't just recite dry facts, no way. If they read about a dinosaur, Melville would translate those abstract numbers into something concrete, explaining that the dinosaur would be tall enough to look right through their second-story bedroom window. On trips to the Natural History Museum, Melville drilled in a vital lesson. There is a profound difference between merely knowing the name of a bird, which is just rote memorization, and truly understanding the nature of the bird. That distinction became the absolute bedrock of Feynman's deep physical intuition. Just track this rapid academic ascent. Despite being rejected by Columbia University due to strict anti-Semitic quotas of the era, Feynman went to MIT and thrived. He actually taught himself quantum mechanics because the undergraduate courses literally didn't exist yet. Then he applied to Princeton, where he achieved an unprecedented perfect score on the graduate math and physics entrance exams. Under physicist John Archibald Wheeler, he completed his PhD in 1942. But his life permanently changed when World War II broke out. Robert Oppenheimer personally recruited him to join the top-secret Manhattan Project at Los Alamos. Now, this era was intensely bittersweet for Feynman. While he was managing calculation teams for the Atomic Bomb Corps at just 25 years old, he was also grieving. His high school sweetheart and young wife Arlene tragically passed away from tuberculosis just 1 month before the Trinity nuclear test. Now, what's really interesting about this slide is this specific number, 125. That was Richard Feynman's high school IQ score. While it's highly respectable, theoretically, it is totally unexceptional for a generational genius. In fact, his grades in history and literature were actually near the bottom of his class. Feynman himself found this whole thing incredibly amusing. Years later, he famously and jokingly declined an invitation to join Mensa, telling them his IQ was simply too low to qualify. Chapter 3. Rewriting the Laws of Physics, Bouncing Plates, and Nobel Prizes. So following the war, the deployment of the atomic bombs and the devastating loss of Arlene plunged Feynman into a really profound depression. He took a teaching post at Cornell, but he just felt completely creatively burned out. To cure this, he made a major philosophical decision. He decided he would stop worrying about the quote-unquote importance of his work and just play with physics for fun. One day, he's watching a student toss a wobbling plate in the Cornell cafeteria, and he playfully calculated its motion just for pure amusement. That spark brought him back. He then used that exact same visual intuition to tackle quantum electrodynamics, or QED, which is how light interacts with matter. At the time, the existing equations were totally broken. They kept giving impossible infinite answers. While other physicists were using dense, highly formal algebra to try and solve it, Feynman approached it visually. He invented what we now call Feynman diagrams. Instead of getting lost in the math, he used straight lines for particles like electrons and wavy lines for photons to map out interactions. It was so completely alien that titans like Niels Bohr initially objected to it, but it worked flawlessly. By stripping away all the academic jargon, he solved the infinite energy problem visually, shocking his peers and ultimately winning the 1965 Nobel Prize in Physics. When you step back, the sheer breadth of his work is staggering. Beyond QED and nuclear physics, just consider his incredible foresight in fields like material science and computer science. In a legendary 1959 address called "There's Plenty of Room at the Bottom," he practically single-handedly conceptualized the entire field of nanotechnology. And then, 2 decades later, he observed that classical computers couldn't simulate quantum reality, so he proposed the creation of computers based on quantum superposition. He practically willed modern technology into existence decades early. Chapter 4. The Bohemian Scientist. Bongos, Safes, and Art. In 1950, Feynman moved to Caltech and explicitly rejected the stereotype of the buttoned-up, narrow, introverted scientist. And this brilliantly illustrates who he really was. Back at Los Alamos, just to prove a point about security vulnerabilities, he would crack the top-secret Mosler safes containing nuclear secrets and leave humorous notes inside for the military to find. He played Brazilian bongo drums in Caltech musical theater productions. He deciphered the astronomical cycles of ancient Mayan codices just for the fun of it. He learned to draw and ended up producing highly prized oil paintings under the pseudonym Ofei. He even launched a decade-long quixotic quest trying to penetrate the Iron Curtain just to visit an obscure Soviet republic called Tanu Tuva, simply because he liked how its capital city was spelled. Stacking all these eclectic eccentricities together really highlights his boundlessly curious, fiercely anti-authoritarian nature. Chapter 5. The Feynman Philosophy. How Not to Fool Yourself. Let's look at the most practical takeaway for our own daily lives. His bohemian curiosity connected directly to his deepest philosophical tenets. The first principle is that you must not fool yourself, and you are the easiest person to fool. That is the absolute bedrock of his secular worldview. Feynman was an avowed atheist. He argued that the universe was just far too vast and complex to merely serve as a stage for human drama. But at the same time, he was deeply respectful of the humility found in true spirituality. Above all, he championed radical intellectual honesty, teaching that the only true failure in life is the arrogant assumption of absolute knowledge. He constantly warned society about what he called cargo cult science. He compared flawed modern thinking to Pacific Islanders who built wooden headphones and bamboo antennas after World War II, hoping to summon cargo planes. They were mimicking the outward forms of investigation, but they completely lacked the vital inner mechanism of rigorous skepticism. True science, Feynman argued, requires you to bend over backward to prove how your own assumptions might be wrong. When you contrast those two things, you get Feynman's ultimate cognitive defense mechanism against modern misinformation and institutional arrogance. Chapter 6. The Final Act. The Challenger and the Final Mystery. As we move into the 1980s, an older Feynman, who is now battling 2 incredibly rare forms of cancer, accepted an appointment to the federal government's Rogers Commission to answer one devastating question. Why did the Space Shuttle Challenger explode? He quickly realized that NASA management was trying to use public relations and bureaucratic obfuscation to hide the engineering truth from the public. They actually knew about the dangers, but they pushed for launch anyway. So what does Feynman do? He cuts right through the politics with a live television experiment that was totally unscripted and devastatingly simple. He took a piece of the shuttle's rubber O-ring, clamped it down with a standard C-clamp, and submerged it in a simple glass of ice water right there on his desk. When he pulled it out, he showed the world that the rubber entirely lost its elasticity in the freezing temperatures of that fateful launch morning. He proved the mechanical failure in front of millions of people, and he concluded his report with these immortal words. For a successful technology, reality must take precedence over public relations, for nature cannot be fooled. By early 1988, his body was failing. When doctors offered him dialysis to prolong his life by a few months, but in a severely compromised state, he flatly declined. He wanted absolutely no part of it. Surrounded by his family, his final spoken words were simply, "This dying is boring." It's a remarkably stoic and beautifully irreverent final thought that perfectly encapsulates his eternal hatred of boredom, right up to his death at age 69. Richard Feynman left us with a phenomenal roadmap for curiosity. He taught us the Feynman technique. If you cannot explain a concept in simple language to a layperson, you do not really understand it yourself. So we'll leave you with this final provocative thought to take into your day. Where in your own life are you just knowing the name of something instead of truly understanding it? Challenge yourself today to use the Feynman technique. Strip away the jargon, admit your ignorance, and ensure that you never ever fool yourself again.